This is here.
Yeah, this one. Thank you. Do you have a presenter view, or where I can see the notes in this one?
How about this?
Yeah, this looks like sweet.
Yes.
Yeah, cool. Thank you.
There you go.
Okay. So, hello. My name is Tibor Auer, and I'm working in neuroscience, neuroimaging, and I would like to reflect on what you have referred to in previous keynote talks. So, in general, there are a lot of things that are already open. So we have our open databases, we have open publications in usually UKs, we have to publish with open access, and so we have the open methods, and we also have some results available. But if something just open, it's not enough. It has to be understandable, and we have to have access to it. And here comes the question of the interoperability and reproducibility, which requires that we should have an easy access of data sharing. We have to be able to find and access the data, and we also have an easy ease of computing the data. And sorry. How can I just move the slides? Okay, thank you.
Oh, sorry. Yeah.
Okay. Yes. So the biggest, so what I'm thinking about is more applicable to neuroimaging, and that's why my title was also about neuroimaging data modeling. So the main problem is, but probably it's applicable to other fields as well. So the biggest problems, there are a lack of common standards. There are no easy tools for accessing the data. There are sometimes the metadata is missing, so we don't know what kind of data it is, and there are also multiple softwares and models which we cannot easily to come around. So in conclusion, there are limited provenance, which means there is only a vague description of the data itself, a vague description of the methods. So if we read a manuscript, for example, and we would like to replicate the manuscript, it's sometimes very hard to do because the author used some internal language or something we cannot really come back to it. And also the results are not described in a standard way. So if you want to do a meta-analysis, you have to sometimes fishing the paper for different values, which you would put into some meta-analysis tools. So the solution what we provide is the so-called neuroimaging data model, which is basically a collection of specification you can find on this website. And it's based on semantic web technologies and extends the World Wide Web Consortium PROV standard for human brain imaging. And it covers every aspect of neuroimaging, starting from the experiment, so the data collection and acquisition, the workflow, the how to analyze the data, the processing, and also the results. So the NIDM experiment part helps you to share and access the data in an easy way, to understand it in an ambiguous way. And also comparing the metadata with the data itself allows you to validate it, to see where it comes from, who is responsible for it. And with all this information available, you can start analyzing the data right from the start with a minimum input.
That was time, but...
Sorry. Okay, just a few left. So NIDM workflow allows you to share the pipelines themselves and understand the pipeline ambiguously. You will know which step is an output and which step is an input to it. You don't have to assemble this pipeline. In the future step, you can just apply this pipeline directly in your data. And the last part is the NIDM results, which allows you to share the data and understand again in an ambiguous way, and also perform an image-based meta-analysis rather than just fishing for p-values, t-values, or variances in a text. So all together, we hope that they will facilitate transparency, reproducibility, and what we hope is the biggest achievement of being open is the credibility. Thank you.